Hello, Chem 155. We're going to go over the crystal violet report workup. So start with your name and the date. There we go. Procedure, I'll leave that up to you. Just keep it brief. Formula weight is 407.99 grams per mole. B0 is 1.00 centimeters. M0, you're going to use your value, but let's say 40 milligrams. V0, use your value, but I'm going to use 0.1 liters. V1, I'm going to use 0.1 milliliters, which is 0.0001 liters. V2 is, again, 100 mils, 0.1 liters. Absorbance, let's say it's 0.065, just for giggles. Now, the number of moles of dye, right, is the mass over the formula weight, right? Well, one thing before we move forward, right? What I'd like to do is use these values and formulas below that are intelligible, that have names instead of cell addresses. So if I want the formula weight, either I can say E34 or I can say F.W, for example. So up in this box here, when this cell is highlighted, I can type F.W, right? Similarly, what I can do is I can highlight this whole block, and I can give the cells on the right the names that are on the left. So what I do to do that is I come up here to formulas, I go create from selection, and it identified the names as being in the left column and the numbers in the right. So that's correct, left column, and I'm going to say OK. And now when I select this cell, up here in this name, it's called B.0, and I can say equals B.0 here, and it gives me that value, right? Or anywhere else in the spreadsheet, it will give me that same value, right? So I'm going to do the same here, and we'll just get ahead of that. Create from selection, left column, OK. Now, number of moles of dye using our new names, this is going to equal the mass divided by the formula weight, right? M0 divided by FW. Right? Now C0 is going to be the number of moles divided by V0, the volume. Right? Now here is a trick, right? We go from C0 to CF, right? So CF is going to equal C0 times V1 divided by V2, right? Now this looks at about 0.9 micromolar. The corresponding extinction coefficient will be A0 divided by CF divided by B0, right, which doesn't numerically change it. And that is 66,298 per molar, and we'll select the wavelength later when we have the spectrum. So now we have epsilon, but we don't know the uncertainty that we're generating in epsilon. So to come over and do the uncertainty, we're going to come over to this page and we'll copy over some data equals eps, right? This is m.0. This is equal to f.w, right? And what I'm doing is I use the tab key to select those. Equals v.0, tab down, equals v.1, tab down, equals v dot 2 and equals a dot 0 equals b dot 0. Okay. So now what we would like to do is we would like to estimate the uncertainties in these values, right? So the uncertainties are going to be S dot M, S dot FW, etc. So S standing for uncertainty, dot, and then the variable name following. So let's assign these variable names over here. I'm going to go to create from selection, left column, okay. And over here, we're going to get the partial derivatives of epsilon with respect to mass, formula weight, etc. And I'm going to use P dot M here, not dE by dm, because the slash character is reserved in Excel. So I'm going to go create from selection. And it's not top row, but it is right column. I'm going to say OK there. All right. So S dot M, let us say that that is half of a milligram, 0.0005 grams, right? S dot FW, let's say that's half a milligram per mole, so 0.0005. V0, now I'm going to use a Vollflas tolerance and say that is 100 microliters, 0.0001. Now this is the uncertainty in that 100 microliter aliquot. This should be lower than it is in a large vol flask, but probably not quite as good. So let's say it's good to 1 microliter, so 0.000001, right? V2 is the same as it is above, 0.0001. Absorbance, I think, is good to 1 milliabsorbance, maybe a half. So let's give it a half, 0.0005. And B is good to at least 1%, probably better. So 0.00, let's say 5. Okay, good. So with all of our uncertainties estimated here, we can see how that results in the uncertainty in various terms, right? So first of all, we need the uncertainty of epsilon with respect to m, right? So because the formula for epsilon is simply the products and quotients of m, fw, v0, v1, v2, a, and b, we can say that the partial of epsilon with respect to m is equal to epsilon divided by m0. Epsilon divided by m, right? Epsilon divided by the mass. The partial with respect to formula weight is equal to epsilon divided by f dot w, right? And etc. on down the line. Eps divided by b dot 0, eps divided by b dot 1. Oops. Do you have to say equals there? Equals eps divided by v dot 1. Oops. And equals eps divided by v dot 2. That's equals eps divided by a oops, a dot 0, right? Oops, sorry, divided by a dot 0. This is equal to eps divided by b dot 0. Okay. So now we need the formula for epsilon. So you're going to have to recall this from the basic, the general formula for the partial derivative formula for the uncertainty in the quantity as a function of its variables. So this partial derivative, not squared, is equal to the square root of, of a bunch of terms there. Oops, don't worry. And so this term here is going to be S dot M squared times P dot M squared, right? So it's going to be the product of these two quantities squared, right? Plus this guy squared times this guy squared 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 plus this guy squared times, you get the idea. And these are all the terms, 1, 2, 3, 4, 5, 6, 7 terms, all products, squared, summed, and rooted. All right, so epsilon 66,000, S epsilon about 1,000. That looks good. So what remains to be done here? Let's put in the formula text for the above. And that will, so I can see the formula used. And the final answer epsilon will equal this. And miraculously, it comes out to about the right number of decimal points here, right? Now, this guy is going to equal this, like this. So this is acceptable. However, what would be better would be 66.2 plus or minus, or 66,300 rather, plus or minus 1,200, right? But this is fine. I don't care that much. All right. So here's the end of part 1. Thanks so much for listening. And in part 2, I'm going to go over how to import the data to get it into this graph right here.